Microsoft. He has been doing this for quite a lot of years. And we actually met while he was doing this. That's what brought us together, basically. That is the major thing that brought us together. And it has been keeping us quite together even on other topics. So Mr. CJ, as usual, would be putting us through some of these things, which normally you would have to pay for, but he's doing it as a service to the community. I remember the last time I tried getting into something like this. It was really expensive. And when I had it did it for free, I was just surprised. I was like, okay, okay. So he's going to give us his knowledge, his experience. He has been working with Microsoft products for quite a while, been doing really well with it. He's going to give us his experience on today's topic. Today's topic is about administering network traffic. With network traffic, it's quite important to understand that no matter what particular part of tech you are in, you are going to be dealing with network. You're going to be dealing with traffic. You're going to deal with networking. You just can't run around it. This is cloud computing, but even in cloud, networking it takes a very, very important part of it. So it would be quite beneficial if you ask as many questions as you want using the chat. So most of your doubts will be cleared. I'll be in the chat trying to answer the questions while he continues with this topic without being disturbed. So thank you very much, Mr. CJ. I look forward to hearing again from you. This should be about maybe the opt-in time. I can't even tell what time it is anymore that we are together on this. I'm looking forward to you doing the usual thing you do. Thank you so much, sir. Please let's begin. And 7 people. Others are coming in now. Thank you. Oh,
Thank
please,
you very
before
much.
you, please, I want everyone to be aware that the sessions are being recorded because we might have some people asking the questions later on. The sessions are being recorded, and there is a YouTube channel dedicated to that purpose. So please stay true with it. And if you need access to the recordings, of course, that will also be available because we know how important these sessions are. And we know most people who are about to take the exams also find it quite important to get on with this, to get access to this information. So thank you very much, Mr. CJ. Sorry for cutting you off. Please, you have the floor right now. Thank you so much, sir.
No problem. Yeah. Yeah. Good evening, guys. It's a pleasure to be here again for another section of Azure Nigeria User Group. Thank you for joining, wherever you're joining from. It's a pleasure to be here. So today we'll be talking about administering network traffic. So most of you already in the cloud or know a thing or two about the cloud knows how important to manage and to set up network traffic. So that's what we'll be talking about today. And we will be drilling down to look at, for instance, how to set up network traffic routing and endpoints. Also, looking at Azure Load Balancer to know what it is, how to use it, and how to implement it. Further, we'll be looking at application gateway. Then to understand what it is, what is the use case, also to look at network watcher. Then further, lastly, would implement a traffic management setup in an Azure environment. And that's basically what we'll be discussing today. So let's get to it. Yeah. So normally, routing is just a way on how to connect, say, one environment, a network environment, to another. Or let's say you have, for instance, a subscription 1 and a subscription 2 within a management group environment, within a tenant. So you will want to, for instance, you have an entity in UK and another entity, a branch office in, say, in US. You want both environments within the same tenant to share data or to share the same server. You can accomplish this using network routing. and then you have to use like endpoints to guide those routing. So that's basically what is routing. And then load balancing is just a way to manage traffic. So you have a lot of network traffic coming in or movement within your network environment. You would like to control it. You would like to make sure that the system doesn't crash or the application doesn't go down. You do it by using Azure Load Balancer. And for the application gateway, is a type of load balancer. The only difference is that application gateway is a level 7 load balancer that allows for instance, SSS offloading, for instance. So in the enterprise environments, application gateway is highly used and recommended to use, depending on the use case. Now, Network Watcher is quite interesting. It's how you monitor what traffic, what happens within the traffic in a network. So it manage, for instance, say for instance, you have an intrusion in your network. You look at kind of IP, what connectivity to which connectivity or which the region or kind of access a device or a net or a traffic within the network. Say you have a visual network, right? So I have a subnet with it. So you have a visual. Say for instance, you have a VPN, and the VPN has like a set of IP range within it, and that goes within a VNet. And then there's a network security group. So a network watch allows you to monitor which kind of traffic, what is the IP range, all those kind of things. If there's kind of intrusion and what, and kind of look at section affinity, all those kind of things. And then lastly, we'll look at a lab on implementing traffic management. So firstly, we'll look at network routing and endpoints. So within this topic, we'll look at system routes. Further, we'll look at identifying user-defined routes. So system route is kind of a routing technique used. Also, we have user-defined routes. So the difference between system-defined routes and user-defined route is the one, the user-defined route is like the routing you yourself, the owner of the network, defined for the routing purposes. It will be okay, I want to do a pairing between a subnet. So one subnet in a VNet should be paired or have access to a given subnet in another subscription. VNet within another subscription, for instance. Then we'll look at a demonstration on custom routing tables and examine a routing example. Further, we'll look at service endpoints and the use cases. And further, we'll look at identifying private link uses. And then a subnet will come further. So system routing directs, for instance, like I said, network traffic between, say, you have a VM, and you have also an on-premises network, and then the internet. So as you can see, you have like, for instance, traffic between a VM in the same subnet, and then VM. So let's say you have between the VMs in different subnets in the same virtual network. So data flows from those VMs to the internet. And then there's a communication between the VNet to VNet VPN for the VMs. Likewise, you could this use case could be also for site-to-site and express route communication through VPN gateway. So site-to-site basically is about, take it for instance, you're in an office environment of your company, and then your device connect directly to the server in on-prem, server at the location of your workplace. That's what is called site-to-site. We also have the point-to-site. Point-to-site is like, okay, your device connect through VPN on the laptop, on the device you're working on, to the server, the private environments of the organization. So for user-defined routes, so there's something we call a route table. So a route table is just kind of rules, a set of rules called routes, and that specify how packets should be routed in a visual network. So basically, you have, like, for instance, you have a user-defined route, and then you have, and this is your environment, the visual network environment, and you have the NSG. So this is your NSG, Network Security Group environment. You have a front-end subnet and a back-end subnet, and there's the system route. So that means that these visual machines within this back end can route directly to the front end. So the front end is just, for instance, say a web app. So this is a web app, say, for instance, Jumia application. You do your shopping or e-commerce web app or website, and it routes directly. There's a VM in the back end that routes to it, to the front end. And then there's a user-defined route. So the user-defined routes are just a custom route that control network traffic by defining routes that specify the next hop of the traffic flow. So it could be this next hub cannot be like say for a visual network gateway, or internet, or visual appliances, or visual network. So further, we'll look at the custom routing tables. We'll look at the route table and how to add a route. And then also we'll look at how to associate table to a route. And then optionally, we could look at how to use PowerShell to view your routing information. So in determining service endpoint uses, so you have, for instance, once again, your Azure environment, and then you have a visual machine with a private IP range. So in this case, 10.1.1.4. And then you have your storage account here. And within your visual machine, there are subnet, and we subnet in a visual network environment. So I have the service endpoint. So what does the service endpoint do? So the service endpoint limits network access to specific services. Adding service endpoints can take up to, say, 15 minutes to complete. Because why? Because the connection, or to achieve this, have to go through the entire endpoint network fiber, and because you are connecting through Microsoft backbone through Express route, and that means the configuration will take a while to go through. So Express routes, you might ask what it is. So Express route is like how an organization connects to their on-prem environment to the Azure environment, and that's Express route. So Express route is just specific. So this connection is specific to, from end to end, from Microsoft cloud environment data center to your on-premises environment. No access to the internet. Not what is Express route. It's quite expensive, but it's quite an enterprise grade way of connectivity used by organizations. So we look at the private link and its uses. So you have a VMs, couple of VMs. You have a private endpoint, and then with an NSG, and you have a set of SQL database, and both are connected. So the the compute, the VMs, connects to this storage account, the storage environments, through a private endpoint. So what that means is that the traffic remains on the Microsoft network with no public internet access. That's what it means. So that's like equivalent of private endpoints, public endpoint, for instance. So often, one of the use cases of this is like you can use this to integrate with on-premises and peered networks. So next, we'll look at configuring Azure Load Balancer. So like I said, Azure Load Balancer is just a way of managing traffic within your environment, how to distribute traffic. Say in a case of, say, for instance, you're shopping at Jumia website and you ordered a couple of items you want to buy. And let's say you want to check out, pay for it, and the system is crashed down, the system is not available. How to solve that is to use a load balancer. A load balancer distributes the load. So for instance, 10 people are logged in or are in a website at the same time at different pages of a website, looking for different content or doing kind of different activities. So a load balancer helps to balance it and make sure that the system can contain and serve anybody who needs it, who's accessing the website. So we'll look at load balancer, how to choose one. So load balancer, Azure load balancer have different types. Application gateway is one of the type of it. We'll look at public load balancer. Then we'll also look at internal load balancer. And then we'll look at the SKUs of the load balancer and look at backend pools. Further, we'll look at load balancer rules and then the session persistence. So it's optional. And then we'll look at a summary. So like you see, what you see here, just different types of load balancer. So first we have the application gateway. Application gateway allows for SSL offloading, and it serves these different protocols. So HTTP, HTTPS, and HTTPS, HTTP2. Azure Front Door is the next one. It's quite scalable. It has an enhanced security point for a security point with delivery point for global microservice-based web application. It's quite really good. I've used it before. And then we have the basic load balancer. So it helps with normalizing the outbound connection and inbound connection. And then we have the traffic manager. So this distributes traffic across global Azure regions. So let's say, for instance, you're working for an organization that have entities or offices across the globe, say in Europe, in America, in Africa, in Asia, for instance. That's a typical use case for that, to use a traffic manager. It's served globally. You can access different data centers and connect and then balance. So let's say in practical terms, what that means is that you might have different users in Asia, different users in Europe, and different users in Africa who are at the same time accessing or using an application at different times. And the best use case for it is to use a traffic manager. So implementing a public load balancer. So you have like TCP port 80. You have your environment. in network environments, I have a couple of virtual machines. So these are web tier environments. So with port 80, you can connect to the public load balancer. So this is a public load balancer, and this connects via TCP ports 80 to the internet. So you need to apply the load balancing rules to distribute traffic across the VMs. So for the implementing an internal load balancer, so internal load balance basically within a VNet. So you have a VNet, and within the VNet, you have created a VNet with private IPs. So that means that only individuals who have access to your VPN protocols can access the application. So you direct traffic. Traffic directed to all those. So in this case, a vision machine via a port. So say for instance, port 1433 to SQL storage accounts. So you only direct traffic to designated applications, so a VM to a storage account. And this traffic are only for the visual network or that uses the VPN to access the Azure infrastructure. So in determining the load balancers queue, so we look at Microsoft offers basic and standard SKU. So, and they offer different features. So for instance, for the basic SKU, you have up to 200 instances. And for the standard, you have 1,000 instances for the backend pool. And availability zones. So for the basic SKU, there's no availability zone. But then with the standard SKU, there's a zone redundant and zonal front end for inbound and outbound traffic. And they have also multiple front ends, so inbound only, and then for standard SKU, inbound and outbound. And then the big difference between the basic and standard is just the SLA. So the standard SKU offers 99.99% SLA, so service level agreement, and for the basic, none. So in enterprise environment, you'll be using the standard SKU. But then the load balancer, say you have a production workload, it's not advisable to use a load balancer. You should use the application gateway or use traffic manager or Azure front door. So to distribute like traffic, you have like a backend address pool that contains IP addresses and visual NIC that connected to a load balancer. So you have a backend pool. So you assigned a name for the backend pool, and the backend pool endpoint could be the basic SKU or the standard SKU. So for the basic SKU, you have visual machines in a single availability set or VM scale set, or you have any VM in a single visual network that includes a blend of VMs available in an availability set and in a VM scale set. So another thing we have is like a load balancer rule. So load balancing rule is just kind of a policy or kind of settings you need to specify on how this the load balancer should be created. So you can combine these rules with the NAT rules. So basically, the NAT is just the rules explicitly attached to a VM. So in this case, you have like you assigned a load balancing rule name. I choose a version, IP version. So you can use IPv4 or IPv6. And then you specify the IP address for the front end. Then you have to choose the protocol. So whether a UDP protocol or TCP protocol, and then you indicate the ports. So you can use port 80, or you can use any other ports, and then the backend ports, in this case, port 80. Or I can also use like port 443, for instance. And then you give a name for the backend pool, and then a probe, a health probe, and then, if possible, assign a section persistence. And then you also have to set an idle time. So idle time means, for instance, say if the system becomes idle, it should time out at 4 minutes, for instance. So section persistence. So what's section persistence? Section persistence basically just tells you how client traffic is handled. So in a case, say for instance, you have a virtual machine 1, a VM2, a VM3, and you have a connection coming from a user who's connected to an internet, and then it hits this connection, hit the load balancer. So the load balancer is here to manage requests, to make sure that a user, a client connecting from connection 1, and a client connecting from connection 2, another client connecting from connection 3, to access or use the internet he or she wants, say in this case, Jumia. And the Jumia websites, the backend pools runs on virtual machine instances. So when the services, these three clients are connecting, what the load balancer does, it distributes the connection to serve these three virtual machine, making sure that each individual can access the Jumia websites and transact what they want. So further, we'll be looking at application gateway. Like I say, application gateway is a type of load balancer that enables SSL offloading. It is very rich in use case, so it has a lot of features, far much better than a typical load balancer. So we look at how to implement application gateway. Further, we look at determining application gateway routing. And optional, we look at setting our application gateway components. And then we look at take a summary. So what does application gateway does? So basically, it routes, for instance, traffic to a pool of web servers based on URL of a request. And the application gateway, so it even rules HTTP settings. It manages web app requests. So the web servers can virtually can be, for instance, a virtual machine or Azure virtual machine scale set or app services, or even on-premises servers. So you have a browser as an application gateway, and there's listings on HTTPS and HTTP, and then there's a rule. You have the energy rules, and they have the backend pools. So the backend pools, virtual machine, and the virtual machine scale sets, and then the servers. So there are two kind of routing for the application gateway. So I have the path-based routing. I also have the multiple site routing. So application gateway have the WAF and the level 7 load balance. It's a load 7 load balancing capability. So you have users who want to access contoso.com website, and there's the application gateway. So it has a WAF, and then you have the pool, the backend pools. So you have the image server pool and the visual server pool. And then you also have the multiple site routing. So you have for the sites, the multiple sites have the Contoso pool site and also the Fabricam pool site. So 2 websites, 2 sites, and then you configure an application gateway in front of it that protects the end users who want to access it and the application and these two environments, these 2 sites, websites. So the first one is contoso.com and the fabricam.com. So in setting up the application gateway components, you will need like the front end IP. It defines the VIP or the ILFP. And we have the listeners. So the listener could be which protocol, which port, which IP, and the certificate, for instance. And then we have the routing rules. So the rules in which you set for the routing to have to occur. And they have the backend pools. So the backend pool is just the visual machines the visual mesh or the instances in which that would need to be assigned a traffic when there's like multiple requests on the website. And then you have the firewall. And finally, the health probes. But I will look at a network watcher. So a network watcher is just basically a device within the net, configured within the network, within the VNet environment, within the NSG, that allows you to listen to, get like a probe or to understand which IPs are active inside your visual network. What is their IP range? And then to understand if this traffic, is it, what do you call it? Does it have the malicious intent? Or what I mean by malicious intent, is it a traffic that is like pulling down your traffic, your network, or trying to short circuit your network, for instance? And also normalize, it also tells you, for instance, the kind of the traffic load of which each network accessing environment. So we'll look at network watcher features. We'll review the IP flow verified diagnostics. Also look at the Nest Hub diagnostics and visualize the network topology. And then we'll look at the summary. So network watcher has different features. So we have, for instance, the original service. We have the IP flow verify. And then we have the Nest Hub. And we have VPN diagnostics. Further, we have the NSG float logs. We have connection troubleshoots. And then the topology. So original service is just that it provides various network diagnostics and networking tools. The IP flow verified diagnosis connectivity issues. The Nest Hub determines if traffic is being correctly routed. And VPN diagnosis troubleshoots gateways and connections. the energy flow logs, which maps IP traffic through a network security group. And then we have the connection troubleshoot that shows connectivity between source VM and destination. And then lastly, the topology. So it generates a visual diagram of the resources. So the IP flow verify is just a packet manager that allows or denies access to a virtual machine. So you have the packet details. It runs on protocol, TCP protocol as inbound. And then you have a local IP address with the local port 3389. And then a remote IP address, which also runs on port 3389. And in this case, the access was denied. So because there's a deny all inbound rule, security rule set to deny all traffic coming in, any inbound traffic coming in. So the next hub basically just helps us to know whether traffic is being directed to the intended destination by showing the next hub. So for instance, in this case, we have a subscription, we have a resource group name, we have a visual machine, we have a network interface, and we have a source IP address and the destination IP address. So in this case, the next hub type just wasn't configured. So basically, it doesn't direct to intended destination. If it's allowed, then it tells you, okay, the next destination you connect. And that runs on a route table. So the network topology helps us to visualize or to see our network setup. So for instance, looking at our VNet, so you have the VNet, the subnets, and then the NSGs within each setup. So it provides kind of visual representation of our network elements. So you can basically view all the resources in a visual network. So you see the association between resource to resource, and also the relationship between the resources as well. So you have the NIC, and how the NIC is associated with the NSG and the visual machine and the IP. So we'll look at a lab on implementing traffic management. So the lab scenario just basically it will be tasked with implementing a hub and spoke topology for network traffic. So the topology should include an Azure load balancer and Azure application gateway. So task one involves provisioning the lab environment, to configure the hub and spoke network topology, 3 to test transitivity of visual network pairing. And then 4, task 4 is to configure routing in the hub and spoke topology. And then 5, and then you have to implement the load balancer. And then task 6 is to implement the Azure gateway, Azure application gateway. And this is the architectural diagram of this task. So task 1, you have to provision the lab environment. And then task 2, you configure the hub and spoke network topology. with the hub and spoke technology. And then the next task is test transitivity of visual network peering. And that's this. Further, task 4, configure routing in the hub and spoke topology. And that's task 4, the hub and spoke setup. So you have a subnet 0 in a VNet environment. So VNet with IP range 10.62.0.0/22. And task 5 is to set up a load balancer. This is a gateway application load, but this is a load balancer. An application gateway. And task 6 is the set up the application gateway. So the application gateway, this application gateway, and within it, it's a resource group RG5, and it's connected, it balances load within the subnet 10.63.0.0/24, the RG, so the RG1, as well as the RG1 of 06, AZ106, RG1. So the different subnet categories. So we have subnet 10.62.0.0/24 and 10.63.0.0/24. So these are internal subnets with internal private IP addresses. So if you would like to do the lab on yourself, you just have to look at this topology, and then you could do it, and then follow the slides and set it up for yourself. And that takes me to the end of this presentation.
Thank you so much, Mr. CJ. That was very, very insightful. Thank you very much. So, of course, if you have any questions, please use the chat. We definitely will follow up on the chat also. For those who do not know, like I said earlier, Mr. CJ is a Microsoft MVP and is based in the Netherlands. And he has been doing this for quite a long time, very, very long time. And I actually respect that. Thank you so much, Mr. CJ, for putting this on and for taking your time out to give us this knowledge. Thank you very, very much. I know how busy you get, of course, and I'm always appreciative when you do this. Thank you so much.
It's a pleasure to have me. Yeah. So if there's any question,
anybody, yes, any question, if you have any question, please, I think you can ask at this particular point. So we are not getting questions from anybody. Perhaps someone, perhaps you would like to use the chat. You feel you do not want to go ahead with asking right on the chat. You could definitely just use the chat. And if you do, that's if you do not want to use the audio, of course. But Mr. CJ's explanation is always straightforward, as always, and quite clear. So definitely, there are not always questions that would be contradicting. So of course, you could use the chat. And if you are interested in having the recordings are definitely going to be uploaded, and everything is going to be done accordingly. Mr. CJ, I have to say thank you again. if I'm to keep on saying it, I'll just keep on saying it because I know how important it is, especially when you are in the world of Microsoft. generally in the world of Microsoft. It's not as easy to have someone who is top level, who is already in the system, giving us that information. Because Microsoft is actually fast growing right now, really, really fast growing. Incorporating a lot of products every day, lots of extras. Sentinel is growing so large. We have their privileged identity management system also growing. Microsoft Purview, a lot of things are growing at the same time with Microsoft. So it opens up this unending needs or unending opportunities for professionals to come in. And for the professionals to function, these topics are actually fundamental to every professional in Microsoft, which is why it is really, really appreciated, which is why I really appreciate it on my part, because I know how far it goes with it. Thank you so much, Mr. CJ, and everybody in. Thank you so much for being here also. I hope you were able to gain the knowledge being passed out. And, I hope to see you again next time. Mr. CJ, please, any words you have to give us before we end the meeting?
Nothing from my side. If there's any question, you can always reach me on LinkedIn as well as drop me a message and I'll comment it. It's a pleasure to have you guys. Enjoy evening. Bye, guys.
Bye.
Ciao.
Yes,